Welcome students to the next module from the chapter Chemistry in Everyday Life. We have started learning about chemistry in medicines. In this module, we will learn about narcotic analgesics. Now children, narcotic analgesics. Remember, these were the analgesics which are going to induce sleep. So, what these do is, they produce depression of the nervous system and they relieve pain instantly. What are the examples? The examples are morphine, codeine and heroin. Let's see when are narcotic analgesics used. First, narcotic analgesics, they reduce pain during fractures. Second, they reduce post-operative pain. Third, they reduce pain due to severe burns. Correct? Now children, what we see is there is a big setback. While using narcotic analgesics for a long time, the person may be addicted to them. And the adverse effects may be produced such as vomiting, dysphoria, fatigueness and mental confusion. Now let's see the examples. First we start with morphine. Yes children, morphine, I put the structure here and we will draw it together. First we draw 3 cycles, yes, and attach an oxygen. Now children, we attach OH group at both ends. And now here comes the nitrogen, CH3, CH2 and one more CH2. This structure which we have obtained here is called as morphine. Now the next two structures which are codeine and heroin are derivatives of morphine. So let's see. What we see is codeine is nothing but alkylated morphine. Yes. So we see here, let's put this structure back up there and let us start drawing it together. The basic structure of morphine will stay the same. These 3 rings and the oxygen here, correct? The basic structure of morphine. And OH here. But children, instead of having one more OH there, the H is now being replaced with CH3. Hence I say it is alkylated morphine. And the remaining of the structure is exactly the same as morphine. And this structure here children is codeine. Now let's come to heroin. Heroin also starts off with a structure of morphine only, but it is a derivative and it is known as an acylated derivative. Let us see why. First we start off with our structure of morphine and the oxygen and the remaining part is the same. But here, instead of having OH at 2 opposite ends, the H is replaced by COCH3. Yes, so it is known as acylated morphine. Now children, we come to non-narcotic analgesics. In non-narcotic analgesics, the commonest example is aspirin. In this module, we are going to learn how aspirin is made. Let us see. Non-narcotic analgesics are mild analgesics. They are antipyretic. Antipyretic means that they can be used during fever. Fever is known as pyrexia. So if I say they are antipyretic, it means that it will reduce fever. Also, they can be used as anti-inflammatory. Yes, and what we see is they can be used also during headaches, during colds and also during any tissue swellings. Now let's see, the example of narcotic analgesic was aspirin. Let us see how aspirin is made. First you take salicylic acid and you treat it with acetic anhydride, and what we get here, yes, the COOH part remains the same, but in OH part the H is replaced with COCH3. Now H is replaced with COCH3. What we see is, children, OCH3 means methoxy and COCH3 means acetoxy. So children, what we got here is said to be aspirin, and this is how aspirin is made by treating salicylic acid with acetic anhydride. Well, this is known as aspirin synthesis. Till the next module children, take care.